Welcome to the Exposure Assessment Solutions channel. This is the first in a series of videos introducing the Task Exposure Assessment Simulator. The Task Exposure Assessment Simulator, also known as TEAS, is a program designed to predict occupational and consumer exposures. This video will be a short introduction to TEAS. Future videos will show you how to predict far-field and near-field exposures, short-term and peak exposures, calculate generation rates, near-field flow rates. I will also produce a video on calibrating and validating TEAS models, and there are a number of option settings and other features which will be covered. TEAS implements the well-regarded well-mixed room models. For example, here we have the one-box well-mixed room model for predicting far-field exposures. We have a room with a volume, air flowing in, air leaving the room, taking contaminant with it. We have a contaminant source somewhere in the room generating a vapor or a fine particulate. TEAS includes not only the standard one-box model, but the one-box model with room recirculation, a local exhaust scenario, local exhaust combined with some form of room recirculation, a local exhaust that cleans the air and exhausts it back into the room, and finally a local exhaust with room recirculation coupled with a general room recirculation. TEAS also includes the two-box model, where we have the one-box model, but inside the room is a zone of high concentration near and surrounding the source. So we have a near field, air moving into the near field, and air moving out of the near field, taking contaminant with it. TEAS also has variations on the two-box model. The two-box model with general room recirculation, some form of local control exhaust into the outside, local control exhaust into the outside coupled with room recirculation, a local control exhausting to the inside, and that combined with general room recirculation. TEAS can be used to predict a single or repeating task concentration profile within a shift and its time-weighted average, task exposure profiles, a single shift time-weighted average exposure, and single shift time-weighted average exposure profiles. It can also predict short-term exposures for comparison to STELs and peak exposures for comparison to ceiling limits, IDLHs, and lower explosive limits. So finally, we're going to take a look at TEAS. It is a program that I designed to help industrial hygienists or occupational hygienists predict occupational exposures using the standard well-mixed room models. TEAS is set up in a structured fashion. You first describe a job, shift, substance, and OELs. You add one or more tasks. You simulate random exposures. You evaluate the results, that is, compare them to the limits. And finally, create a report. We can do other things, which we will touch upon just briefly today. We can calibrate a one-box or two-box model if we have measurements. We can predict emission rates, application masses. We can calculate near-field volume and ventilation rates. I have written a help file and a tutorial to assist you in learning how to use TEAS. To demonstrate TEAS, I will open up a file that I have already prepared. This scenario involves cleaning parts using a degreaser solution which has as its active ingredient methylene chloride. I have described the job, set a shift length, provided substance information, and various limits that I am interested in. I know that my limits are in parts per million, so I should set the output units to parts per million and set the number of decimal places to something reasonable, in this case 1. Let's go to our Task Manager tab. We have a task that's already been loaded. We can add additional tasks if we wish. We can delete those tasks, unneeded tasks. Each task will have a frequency, a duration, and various variables. In this case, we have a 2-box constant emission general ventilation model. To change this model or to add a model, we right-click on a yellow row for a task, which brings up the task model selection form. I can pick a 1-box, a 2-box model with LEV, LEV with return, with recirculation. In this case, I just want a standard 2-box model. And once I have selected the model I want, I click Select. I've already selected a model, so I do not want to override it. For this particular model, we have a generation rate, a room ventilation rate, a room volume, a near-field volume, a near-field ventilation rate, the time of generation, the time that the source is on, and T1 and T2, which are worker placement variables. T1 is the start time in the near field, and T2 is the end time in the near field. If T1 equals the start of the task, then it will be set at 0. If T2 is the end of the task, we set it to, in this case, 60. This indicates that the worker is in the near field for the entire 60 minutes. For the generation rate, I am describing it using a triangular distribution, where the mode is 5,600 milligrams per minute with a minimum of 2,000 and a maximum of 11,000. The room ventilation rate I have set in units of air changes per hour, and I'm assuming that the ventilation rate can change between 6 and 12 air changes per hour across the year. I have a fixed value for the room volume and the near field volume. Near field ventilation rate I am describing using a triangular distribution. How I came up with these various distributions will be described in other videos, and they are described in the tutorial and help file. So I'm describing the near field ventilation rate using a triangular distribution, the time of generation also using a triangular distribution. Once I have a task completed, I go to the Job Simulation tab. I check my model to make sure that it is predicting what I want it to predict. So I click on 1 TWA, and it will generate simulated worker days. You can see that the frequency or the number of tasks per day vary. We can click on the random day chart, brings up a larger version of it. We have the concentration profile per task or set of tasks on the right, and the time-weighted average for each task on the left. I'm interested in a full shift time-weighted average, but I see that my sets of tasks generate TWAs ranging from 60 minutes to several multiples of that. I want a full shift TWA, so I come over to Task Options. The default setting is to calculate a time-weighted average for a task or series of tasks. I will set that to a shift time-weighted average, where 0 exposure is assumed for the remainder of the shift. Check the output. It's predicting full shift 480-minute time-weighted average exposures. Now I can predict the entire exposure profile. So I click on Start. TEAS generated 1,000 simulated full shift exposures and has displayed them as a histogram, a log probability plot. TEAS calculates various statistics. If I click on the histogram, it will bring up a larger version of the histogram. I can redo the simulation. We see that the histogram changes with each simulation. If I set the number of simulated days to 10,000, for example, I get a nice, stable histogram. Now this is the near field histogram. To calculate the far field exposures, I go back to my task model, set T2 to 0, go back to this Job Simulation tab, click on Start, and I get the far field general room exposure profile. I'm going to do a few things here. The OEL is not on the histogram, so I'm going to click on the histogram, open up options, set a min and max value for histogram of 0.1 and 100. That brings the OEL into view. I don't want to view the statistics, so I will eliminate the statistics. I will save this histogram, right click, opens up a menu system. I can save that histogram. That's the far field histogram. If I go back to tasks, set T2 to 60, now I will be able to predict the near field exposures. Start the simulation again. And now I have both the far field and near field exposure profiles relative to the exposure limit on the same histogram. If I am satisfied with the simulation, I can click on Build Report, which will take all of the information, the job information, the substance information, the exposure limits, the various task models. In this case, I have one task, and all of the variables are listed with each variable model as well as the units. We have various options that are in effect. They are listed. The statistics, the various graphs that are generated, and then this can be saved as a .doc file. For more information on TEAS and information on how to purchase a subscription to TEAS, please visit my website at www.easinc.co. Thank you for your time.